Hello everyone, welcome to TryRight, the new era of learning. Myself Rafiq. Today we're discussing about recurrent neural networks. Okay, so what is recurrent neural networks? Recurrent neural networks are the type of deep learning model specially designed to handle the sequential data that where the order of elements matters that makes RNN ideas for time series predictions and natural language process NLP like in text generation, language translations, and in speech recognition and for video analysis. Okay, so recurrent neural networks. Let's see. Recurrent neural networks. It is a different for regular neural networks, right? In how they process information while standard neural networks pass information in one direction, like from input to output, right? RNN feeds the information back into the networks at each step. Okay. Right. Every wonder how chatbots understands your questions or how apps like Siri and voice search can disappear your spoken request. The secret weapon behind those impressive feats is the type of artificial intelligence called recurrent neural networks. Let us say small recurrent neural network example. So it will be more easy to understand for you. So I will take a easy way of taking translator. So let's see. Have a translator like here. It is also one type of theory using recurrent neural network. So I'm typing here. So right in English too, I choose any other language like called. Okay, I use Japanese. Okay, I use hello. It converts to konnichiwa, right? Or in Hindi, I want to say in Hindi or in Telugu. See how the data will display like that. So that is the behind the scenes of that the speaking of the Google. So we use recurrent neural networks. Okay. So by using that, we can easily assist our request, voice request to the our chat box in chat boxes or in anything. See the like if you're using Siri, Alexa, or something, it's recognize our voice and it assist what we want us, right? In the since we use the RNN network. So in the architecture of RNN, we have the process of step by steps through the loops at each step. Okay, so it takes input vectors and maintain the hidden states and update the hidden states you okay and produce an output final output. Okay, so we can see the sequence of RNN can be unrolled in each cell, shares the same parameters, but updates the hidden states based on the previous one. Okay, so we can say the limitations of vanilla RNN, right? Vanishing the guardian problems when sequence are long to the guardian during the backpropagation become too small updates early layers efficiently, right? Where exploding gradient problems that opposite of vanishing, gradient grow to the large description. Okay. So we use short-term memory also for standard RNN struggles to remember okay back in sequence. So in the concept of like this, we use to overcome the solution, we use the LSTM and GRU. It is a mechanism in which we use in RNN. For the before we like to explain it. Unlike standard neural networks that excel at the task line, images recognition, and recurrent neural networks both and a unique superpower memory. This internal memory allows them to analyze the sequence, right? Analyze the sequence, the data where the information order is circular. Sorry, crucial. Imagine having a conversation. You need to remember what was said earlier to understand the current flow. Okay. Similarly, RNN can analyze a sequence like speech or text, making them perfect for machine translating and voice recognition tasks. All through RNN have been around since the 1980s, and recurrent advancement like long short-term memory and the exploration of big data having the unleashed through potential. Okay, so in since of 1930 we are using the recurrent neural network because from the earlier period we use the translator like in the olden systems We use the translator, like from one country to another country, we use the telefications transports, right? So for the communication, we use that. From since that the RNN is developed too much, okay. After the behind the RNN development, we use the NLP, right? Natural language process. We use the natural language process to easy to understand to communicate with the system, okay. If you're saying something to the system will identify, and the system will give the output to you based on your input, speech or text. So like that, it developed by the NLP, right? After that, it get more and more advanced steps, okay. Now we can, now in the current generation, we can easily interact with the systems, right? We can easily assist our systems, like by using, by saying commands, okay. By giving input as command, we can do whatever we want, right. So in the system, we use to solve those problems for advanced RNN variants. So we use LSTM, means long-term, short-term. For long-term, short-term memory, we call it as long-term, long short-term memory also. So it adds memory cells and gates to the control what information to the remember, forget. Okay. Can long-term can learn long-term defense. Okay. It use dependencies and uses of it, means input gate. We have the one input gate, one output gate, one forget gate, right? So from the input gate, we used to decide what new information to store from the input side. Okay, we used to like use, and we use out forget gate has decide what to describe. Like if you the data is proper way, so its command like it's command to the enter into the input section. Like when you're giving input has a one thing, if the data is validated, so it used to command it to the output. When it's not a proper validation, so it removes the data. It forgets the data. It forgets the data. Like we used to use pre-processing step. Okay. So output gate is must be decides the output form of the current memory. Okay. While coming to the GRU, we use gated recurrent unit. It stands for gated recurrent units. So similarly in the LSTM, but which fewer gates, reset and updates, less complex and faster than train it efficiently. The reset gate and update gate use mostly used to if the data is stuck at a certain time, so it restart from the starting. We use the reset gate and update gate in little bit in conservation or text. We use something add. We can use it to modify with that. With that, it is useful application to us. So in the applications of RNN, we use the language modeling, predicting next word in sentence. Like if you text something, if you text something in chat box, while you all see that when you're chatting with someone else in WhatsApp or a Telegram or Instagram, you're typing something, right? But while typing, you can see that some words can be already retyped. Okay, but while you use past sentence, it will be comes into the present, right? If you're typing hi dude, I'm going some I used to planning a trip, like I'm going to the office. Okay, right, you're reporting to someone I'm going to the office. So while you're texting I'm going, it immediately generate a text called office or somewhere market, like that. So it is based on past experience. Okay, the language modeling and machine translation, sequence to sequence RNN converts one language to another language, like we previously now we see that in Google. So we translate in one language, we assign the command as one language, it translates into another language that we use, and speech to text. Like we are just entering the speech, right? In the command, we just entered the text, right? Hello, it give namaste and namaskaram in Telugu, right? We just assign the text and it comes into output like in speech to text or text to speech, like we use. And music generation, predict next notes in the sequence, like if you're predicting a music, the lyrics will get the copied of next lines. It may be sequence ordering, like that. Okay. So stock prediction, model sequence, financial data, like if you can easily predict the stocks. Okay. From this and recurrent neural networks, RNN is a more like artificial neural networks. Like it is a part of artificial neural networks that are mostly employed in speech recognition and natural language processing (NLP). So deep learning and the construction of the models that mimics the activity of the neurons in the human brain uses RNN. Okay, text, genomics, handwriting, the spoken words, the numerical times series, data from the sensors, stock markets, and the government agency are examples of the data that recurrent networks are meant to the identify patterns in a. So a recurrent neural network resembles a regular neural network with the addition of memory. state to the neurons. A sample memory will be integrated into computation. Okay, right? So this is the main uses of the RNN we use. We assign the input as speech in speech recognition. We assign the input as a speech and output has we use the fizzy, wizzy, was, beer, fizzy, wizzy, I know here. So it is legitimate. It is a rhyme. So you assign an input has a speech, it output gets into text. If you assign an input has a text, it assign the into voice. So music generation, in music generation, we want to identify the symbols like music symbols. So you assign a symbol to symbol, we can arrange the music output. And sentiment classification, nothing but it is one of it depends on the decisions of the feedback on the of anything. If you're running a product based company, you it depends on the customers. If you're running a service base, it depends on the employees like that. Okay, clients. So overall, it shows if you think decent effect the plot, can you have better like if you give the good, bad, average, medium, excellent like that, it gives the emoji like a rating. Output has output, and DNA sequence analysis. If the matching DNA where the DNA gets matched, we can easily set the matching DNA by the output. So machine translation like that. We communicate in one language and it gives in one our understandable language. And video activity recognition like if you say confirm some pictures, you like what the image is doing, what the pattern identification, so it must be comes the output as it is running while walking, while riding a bike like that. So name entity recognition, in name entity recognition, we use something in the sentence which is the name like I get three Egatrid and says John. So Snow. So the both are the names to identify the names. Like that, we use the RNN feature. Okay. So types of the neural networks RNN. So we have the types of we have four types. One to one, one to many to one, and many to many. From the one to one, we have a single input. Also, and based on the single output. Based on single input, we have single output. We have a one to one recurrent neural network. In one to many, we have only one input, one single input. But based on that one single input, we have multiple outputs. And many to one, in many to one, we have multiple inputs, and based on the multiple inputs, we have outcome as one output, single output. And many to many means if we have multiple inputs, it generates the multiple outputs. Okay, like the sequence will behave like this. So generating step by step, one to many to many like that. So the sequence may form like that. So instead of that, I used to easy way of the communication of like that. So I used to explain line by line to easy understandable to you. So I take paint here, like data. I can see how. mm let us draw here. First, I'm explaining one to one, right? So first, I'm explaining here. I'm explaining here one to one, one input to one output, right? One input to one output. I'm explaining here. So about this, I calculating here one to one, right? So from the one to one, right, I am designing here one of label data. So I'm drawing a neural networks of one to one. We can say so instead of that, I take like this. It's better to visualize in one to one. So I this is my parameter of translation, and I had one input base, and I had output here. Like that, I had input and output, right? So from this input, I send like this. In here, I send it like this here. One 200. Okay, little bit. Yeah, you here one other circle here. like the data will be connected here. Okay. So of this one-to-one is mostly used for the one-to-one is mostly used for here we have the entering input has for translation it is if I enter here hello in English it represent here in Telugu in the namaste in Hindi if you take namaskaram in Telugu like that it translate one-to-one like I assign the one input here and it gives me the one output like that. If I give input as hello, it is the layer is called the middle layer is called the hidden layer of the recurrent neural network, and it translate into the one single input, single output, right? We assign the single input and single output like that. We assigning the single input, it generates the single output. We use in motion translator, like we see here. We insert the hello instead of hello, it gets in Telugu like single input and single output like that like the sentence we use here. Okay, and now the part here is now one to many. From one to many, we use a function called let us take my name is let's generate my name is what is this question mark my name is I generate sorry my name is I generate my name is I generate my name is okay. From this is my sentence okay. This is my sentence right. So this is my name is this is my sentence. So from this sentence, I have to generate a line, like how it is generated. So instead of take my name is here, I want to generate a name called Rahul. Okay. From this my one input and want to transfer it to many input. How it works means so taking a variable one input here, one based input here, and from this we take multiple outputs here. So I want to make some distance in between this. So that's better. You get some little better understanding. For better understanding, I want to give some space between this. It was these all layers also. These all layers called neural layers. These all layers called neural layers. So from this, as a hidden layer like this. So from the data called from these two and this not like this. In this is translate from the output of the data like this. So assign data here. So this is my data. So here I am in assigning my input. Okay, here I am assigning my input as Rahul. Here I am assigning my input as Rahul. I am assigning my input as Rahul. So here what will happen? It recognizes the order, right? It recognizes the orders here. These all my networks here. These all my networks here. These all my neural network connections. These all neural network connections in layers. Yeah, it's done. So from this, the diagram will consider like this. So this is my input. So what will happen here means, so it takes to here, right? It gives the input. It's all my one input block. So it will happen like it here it generates here, or it splits the name. Like you are assigning what is my name, right? Here, sorry, here I want to take what is my name. I'm asking here input has name, right? I am asking here input has name, not none. I'm asking here name. Like my input has my name. So it takes input has name. It recognize the name and it output. So it follow like this. The each and every input it takes like this. So it take like this. So each and every input, it gives me here A, here H, here U, and here L. Like you see here how the value is founded, and at the end block, it gets end here. Like it gets end here. Okay, so we see here we can see that we have a single input layer here. From here we assigning the single input. From here we assigning a single input. From based on the single input, uh, so we're assigning a single input. We're assigning a single input. So based on single input, we are assigning a multiple outputs here. So this is nothing but one to many. We called as one to many. Okay. I hope you understand on this one to what is one to many. What is I am assigning my name and it's giving the raw AHUL. Each and singly divides the split the character of the name and it divides in letters. So I'm assigning what is my name in input and it takes output as Rahul at the end. Okay. So this is my end. Now next topic gets and many to one. Okay. Now we take has many to one here. So we can take many to one. Here we take many to one. So from the many to one, I consider here has this is my favorite movie. Let us consider this is my no, this is my movie. I take this is getting too long. So I take the movie. This movie is very good. Sorry, we can take very nice. This movie is very nice. I take this sentence has many inputs. Okay, this consider has this movie is one. We take five neurals and it presents the one output here. Okay, how it process how it process means let us see here. I'm assigning the outputs as five. So I'm assigning here value as five here. To each neurons it gets a connection here. Here is all my input layers here. Okay, from this is all my input layers. Okay, from this input layers, I am assigning here values called like I am assigning the values called from here x1. I am taking x1 has I am taking here x1. What x1 has, and this is this has one out this, and from here I am taking same like x2. What for x2 I am doing movie movie. Okay, and from here I am taking x3 here. From x3 I am giving is, and here I am assigning x4 has v or y vary. Right, here I am assigning x5 has nic nights. So those are my inputs. Okay, so these are my inputs. So I am here assigning. We can see assign a0 here because it's starting. If I use for calculation, like here we can see a equal to 1 in each and every set we calculate like this. So a equal to 2 like this up to end of the a equal to n. And you can see a equal to we have 5 let we take let's take 5. Okay, a equal to just take 5. Okay, it's done. So what will happen means each and single input here, those all my inputs, right? Those all my inputs here. So what will happen means, so these all my inputs, right? These are my inputs. This movie is very nice. This is my input. So it generates a output like it is many inputs. I generate one output like it's user rating here. Like this, it used mostly it used in sentimental analysis. It used in sentimental analysis. Many to one concept is mostly used in sentiment analysis because it generating use for reviews. So the movie is very nice. Means I giving rating here 1 star or 2 star, 3 star, and here 4 star. Like that, I giving a rating here. Okay, like I am giving rating. For this, I get the one in from here. You can see here. I assign the inputs as one, multiple inputs, and only single output in sentiment analysis like we see here. So we can see here sentiment classification. We give multiple inputs here about the movie description. It gives the movie review. It gives the according to your movie review or something anything. It gives the according to the sentiment analysis output. Okay. So the basis of like that it will depend. So many outputs, one input like that. So I hope you guys understand about this concept. So now final concept. Now final concept was many to many. Like okay, many to many. So it's to get some more tricky. Like so, I used to take it divides the grammar. It checks the grammar. Mainly, it used to check for the grammar. So I take again. I take Rahul. Rahul buys a Rahul buys a new iPhone, right? New iPhone. Rahul buys a new iPhone. Or we can take instead of I have single doubt. Okay, let us be iPhone. Here we check one grammar point here. Rahul bring new Apple iPhone. Okay. Instead of this, we can like this. Okay. Rahul bring new iPhone. Okay, new Apple iPhone. Rahul buy a new Apple iPhone. This is concept called many to many, right? This concept called many to many. So in this concept, what will happen is We take Rahul as one input and buy a new Rahul buys a new Apple iPhone. Where six inputs, we get the six outputs. How many based on input we get it. So here what will happen means let's check it. So here Rahul is a name. Okay. Rahul is a name, right? It is a person. Rahul is a name. It is a person. Rahul is a person, and here we can see new Apple. Apple is here. We can see Apple is here. So instead of Apple is here, uh, fruit or brand. Why I think I said wait, why one I can say here, which is the fruit of brand, right? So here next thing is what Apple, iPhone. iPhone is a product. Okay, iPhone is a product here. Okay, iPhone is a product here. So like this, it divides the grammar. Okay, so Rahul is a person, buy a new apple. So why I said apple, fruit, and brand means. So wait, it checks the FRUIT. All right, it gets some little mistake. So it's get like that apple or brand. So we take here. It get, here we can take uh fruit or brand. Because I said because why fruit means if you text in ChatGPT or OpenAI or in something any Copilot or any AI application. So if you search just type Apple, it becomes which was your application like. Let us see. I will show you how does it works. Copilot. So I'm using app early Apple. See, it gives the some little bit information. Apple, it takes. Are you thinking about the fruit or the tech gain? Maybe something entry else entry. If it is Apple, the company there has lot getting iPhone. See, it's mentioning it is about fruit or it is Apple. So like that, the double check grammar it will be checking here. So iPhone is nothing but it is the product. From here, like the classification is done doing like classification is done by there. So again, we call the data here line by line based on multiple inputs. Okay, from it gets the proper final output. And here, what will happen? So based on multiple inputs, we give the multiple outputs. So what is my inputs here? So my input is what is my input here? So it give Rahul as input. Rahul is my input, and here my input is BUI by, and here my input is only A. Here my input is new. Here my input is Apple. Here my input is APPPLA Apple. So we take another line here. So we because based on the data grammar, we take the layers. So we take here iPhone. So how it recognize Rahul means it recognize as person. If by it doesn't have any grammar check, so it gives as zero. It doesn't have grammar, so it gives zero. For A, it doesn't have grammar, it gives zero. For new, it doesn't have any check the grammar, it doesn't give. If the product is true, it gives one half, one. It falls zero, right? If the product is true, it recognize the grammar check, right? If you apple, apple means it gives the fruit or brand brand, and it here product. iPhone means product. Like that, based on multiple outputs, we get the multiple inputs right here. Hope you understand here. So based on multiple inputs, we generate the multiple outputs here, right? So this is what many to many. This will work some like this. How the like many to many will be works. Okay. So this is nothing about the CNN RNN. I hope you guys you all understood about that, understand about that, and bye all of you. Thank you for